Hey everyone, welcome back to the YouTube channel. Today I wanted to take some time to talk to you about the new controller. It's taken me a really long time to develop it, but I finally finished the new launch controller, designed to wirelessly launch the rocket very securely from security codes and keys. Inside the controller you'll find a large array of buttons and switches to control everything in the launch site. The controller easily turns on with this key. So you switch this switch and everything comes to life. So over here we have a readout of what the voltage is inside the system. Here we have a screen which displays everything that's going on. This is just a standard 16:2 LCD screen. Here we have a 4:3 keypad. That's mainly to type in security codes so that only I can launch the rocket. Here we have 3 rotary switches. As you can see, they're labelled wired, pneumatic and spare. So the wired switch changes the mode of the rocket from wireless to wired. So if on the launch site something isn't working properly with the wireless system, then eventually I'm going to have 2 banana plugs just here so I can wire up a hardwired launch cable. So that's what this does. The pneumatic switch activates or disables the pneumatic system. So the launch pad has a pneumatic piston to retract the strongback during launch. So for some reason, if that's disabled, then I keep this off, but if I do want to use it, then I can just switch it on. The spare switch is what it says, spare switch. Here we have the emergency stop button, so that's wired directly into the same circuit as the key switch here. So if I press this, you'll see over here, it cuts power to the entire controller immediately. So when this launches, there's a 15-second countdown from when I start the sequence to when the rocket actually launches. During that countdown, the controller sends a bunch of wireless signal to the launch pad, but obviously at any time during that countdown some danger could come. So all I've got to do is slam the emergency stop button, and then the controller can't send any more wireless signals to the launch pad, and obviously it cannot launch the rocket. Just here we have the antenna port. So if I take the antenna out of the 3D printed clip just here, it screws into the port, and that is how everything is controlled at the launch site. So nothing's wired, this is completely wireless to the launch pad. Then here you see we have 3 push buttons with LEDs. So one arms the system, so you hold that down, there'll be beeps and the LED will go, and then when you're ready to launch you hold that down and you press launch, and that will begin the 15-second countdown. Just here we have a pressurized switch. So the launch pad has an onboard air compressor, a little tiny 12-volt one, so I could hold that down and it would pressurize the pneumatic system into the tank that I have. Here we have a button labelled connection. So what that does is you press that, it will send a wireless signal to the launch pad, and the launch pad will send a wireless signal back, and if this LED comes on, it means that everything's connected to the launch pad nicely. Just here we have 3 missile covered switches. So they control different settings once again. So this one's labelled static, so if this switch is on, the countdown will go ahead, it will ignite the motor, except for the clamps on the launch pad will not release the rocket. Instead the rocket will stay on the launch pad and perform a static fire. Just here we have a switch labelled 3 core, so eventually I'd like to launch Falcon Heavy models. So obviously 3 cores, I need to ignite 3 motors. So if that one's on, it's going to ignite 3 motors rather than just 1. Here we have a switch labelled ESC. Now ESC stands for Electronic Speed Controller, for those of you who don't know much about RC cars and stuff. So what this does, when I switch this, is it changes into a mode where the rocket will be in a test stand, and instead of a motor inside of the motor mount, there'll be a propeller, a remote control plane propeller, and once that's on, it will start up the propeller. This potentiometer, as I said, will control the speed of that propeller, and all of that is designed to test the thrust vector control to make sure everything's working nicely there. Just here we have a switch labelled reset, so that's wired directly to the reset pin on the Arduino. So if I press that, the Arduino resets. So for example, I don't know how well you can see the screen just here. Right now it says enter security pin. So I type in the pin, I've just got 1, 2, 3, 4 just for this video. Enter the pin, says welcome Eddie, and then after that it's got wireless launch 1 core. I can switch this to make wireless static, wireless launch 3 core, or I've even got wireless static ESC test, or once again impossible request, because the ESC is only wireless, sorry, there's no hardwired ESC control, so impossible request. What I'm getting to is that any time if something's wrong with this screen, then you simply press resets and it's going to reset the screen. I'm not sure how well you can see that, but that's what's going on there. Finally, I forgot to tell you, just here we have a little DC jack. That's not for charging or anything like that, however I would like a DC jack for charging eventually. What that does is lets you plug in an external 12 volt revolving light, so the orange ones that you find on construction sites on top of trucks and stuff that flash. So it's going to be one of those plugged into there, and during the countdown that light's going to be going so that people who are far away filming with cameras can clearly see that the rocket's about to launch. So that's it for the front panel. Let's switch it over and take a look at the back. The other side of the panel with all the wiring is, as you can see, quite a mess. I did try to keep everything color coded and together nicely into their spots so that I could try to keep it neat. And it is very messy, however it's very easy to follow the wires to where they're supposed to go. Post-production me just here. Just wanted to let you all know that on Instructables I have a really big write-up about the entire controller and everything I've done. That includes all the files that I have, including the schematic for this entire thing. Unfortunately it doesn't have software because that's not finished yet, but it also has all of my planning documentation and everything that I have used to create this controller. Going around you can spot what's what. These are the missile switches, obviously the rotary switches, keypad, LCD, things like that. Then in the middle here you'll see we have 2 MOSFETs. That's because the Arduino can only do a 5 volt output, so the MOSFETs allow me to take power straight from the battery and into something. In this case it's for the wired launch that I'm planning on doing in the future, and for the 12 volt external flashing lights. Down here you can see we have NRF24 long range transceiver module. That's in with epoxy and a washer to keep it straight. Emergency stop button. There's all those basic things. We also have a DHT11 temperature sensor, so I'll be able to know the temperature at the launch site on launch day. Oh, I nearly forgot. Right now you'll see it's controlled by this tiny battery. This battery is actually for the flight computer just here. This is another prototype, but it will be powering the flight computer on the rocket. I have not ordered the main battery yet, but it will be a much bigger remote control plane battery that will power this whole system. This is a very small temporary testing battery. You can see currently it's powered by an Arduino Mega. That was not the original plan. It's a bit of a story to that. So originally I had this Arduino Mega Pro, which looked quite sleek. That was mounted on there. Everything was wired to it, right? These wires took a really long time to make. I had to make them all up. Everything's nicely heat shrink, so that took a long time. So I nicely wired everything into this, which was sitting in there. As you can see, much smaller, much more professional looking. However, when I started testing it, I was thinking that the buttons weren't working because I didn't know how much I trusted this cheap board from eBay. So what I did is I replaced it with an Arduino Mega, and I had to replace all the plugs on every single wire because the Arduino Mega has female terminals, however this one has the male terminals. So that took quite a few hours and a lot of time to fix all that. And in the end I realised that it was just a problem in my code and was not actually a hardware problem at all. So now I'm stuck with this Mega because I'm not going to wire everything back to how it was. Now you're probably all staring at the 2.5-inch speaker just here. That is for a future upgrade where the controller is going to talk. So during the countdown sequence it's going to have pre-recording WAV files that are going to say 10, 9, 8, etc. And then it's going to have the typical things like standby for terminal count and those sorts of things. So that's just a bit of a gimmick. It doesn't really do anything in particular. However, it should be pretty cool. That may or may not be working for the first launch. I do have all the parts for it, but I simply haven't got time to set it up yet. There's a few more things that I'd like to talk about with this. First, you notice that the labels are currently just masking tape with some markings on them. That is not the final labels. Usually I have access to a vinyl cutter, which can be seen on the top here. So they're the proper vinyl cut labels. However, because of the current world situation, I don't have access to that vinyl cutter anymore, so these labels are just temporary. These will be changed to much nicer and more professional labels. The other thing I've had questions about is this open area here with the 4 random screws. So these screws are holding in the controller and prototype board on the back of this, but that doesn't explain the random space. That will have some fancy cursive sort of writing there when the controller is done. However, once again, I don't have access to that vinyl cutter, so I haven't been able to make that yet. I've also had a lot of questions about safety with this. I obviously have the emergency stop button, the key switch, and the security codes. Those 3 things keep it pretty safe, pretty reliable. I've had people concerned about this sending a wireless signal to the launch pad to launch without me expecting it. That launch physically cannot happen without the security code, and it will be programmed into the system to only launch when I hold arm and press launch. People have said that I should be using a relay to cut off that circuit. I'm not going to mess with that too much. I've also had people say that I should have a fuse inside. So what happens if someone gets the security code wrong? It blows the fuse and then cannot launch. Obviously this whole thing's pretty overkill, but I think the fuse is a bit too overkill, and I'll be constantly accidentally blowing fuses and having to replace them. So I think that is quite unnecessary. In the description down below I'll have links to a really long Instructables about how I made this, how you can make one, and what else you could do with it apart from just a rocket controller. I also have a link to my Thingiverse. It has all the files for the speaker holder and the NRF24 antenna mounts. I also have a link to my website where you can find a bit of information, but the website's a bit run down. And of course I also have links to my Instagram and Twitter. Twitter I post a lot of updates too, so if you want to know more about the project and keep updated regularly, normally multiple times a day, then Twitter's definitely the way to go there. As usual, if you enjoyed this video and want to see more, make sure you subscribe, give it a like. Any questions, comment down below. But anyway, that's the end of the video. Thanks a lot for watching, and I'll see you next time.